as usual, I'm going to start with a little bit of history. So back in the 3rd dynasty of Ur in ancient Babylon, which is in the Mesopotamia region circa 2000 BC, BCE if you want to have it in that notation, land planners had a problem. They had irregular plots of land. They needed to figure out how they could subdivide into equally sized rectangles for things like living quarters, grazing land, cropland, and whatever else they might need in that space, where when they had to figure this out, the problem ended up resolving itself mathematically into the equation x squared plus c equals bx, where they had to find solutions to that equation. An equation that should look a bit like that. And in particular, the solution they had followed an algorithm, where what they did was find half of the value b, then squared that, subtracted c from that value, found the square root of that whole quantity, and then added half of that back, added that back to half of b. Now, it's a little bit hard to picture all of those steps in your head, not least of which because I stumbled over my words a little bit. But it's a pretty common problem, and hopefully, even with my issues there, you recognized a bit of that verbiage. In particular, that wasn't a very unusual thing to figure out how to do, subdividing land into rectangles. It was an issue that the ancient Chinese, Egyptians, and Greeks, among many other cultures, had to deal with, where further work was done on this problem in India and the Arab world through the 9th century BCE. So another few thousand years they spent working on this, and the formula that fit all cases was put forth by the Flemish mathematician Stevinus in the year 1594. Where the version of the formula that we are more familiar with, the version of the formula that once I say it, you will probably remember it now, was put into place inevitably by Descartes in La Géométrie, where what he said was, if you want to find the solution to an equation of that form, you can use the formula x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Or hopefully, you remember that as the quadratic formula and this as a quadratic. It's a problem that people have been studying for a very long time. And maybe those of you who have some etymology on the brain and know a little bit about the Romance languages see the word quad and, well, wonder why a thing that has at most 2 roots and 3 terms has the word four attached to it. And the reason for that is that even though we may want to blame the French again, unfortunately we don't get to do that in this context. It's not all their fault. The reason actually comes from Latin, where the word here that we're dealing with comes from the word square. Again, think of a nice object, the nicest object you can get, that has 4 sides. And remember that when we're talking about where these things come from, when we're talking about where these were developed, is for optimizing rectangles. It was for squaring things. So when you're talking about optimal rectangles, you will inevitably get things that have this form, hence the name quadratic. If you ever go into calculus, you'll actually see that the optimal rectangle is a square. But for us, quadratics are most often the second type of equation that you learn about in algebra, naturally, because, well, they're the second power of x. That's why these often are sometimes called the second-degree polynomial equation of x, where the big tool that we have for dealing with them is an idea called the zero product principle, which says that if we have two things, a, b, whose product is equal to 0, by virtue of the fact that the only thing that when multiplied gets you 0 is 0 itself, it must mean that one of the two pieces, a or b, is equal to 0. And that is what allows us to find a lot of our solutions here. In particular, that's what allows us to use our most popular approach for solving quadratic equations, for finding the roots of quadratics, factoring, which is what we'll look at next.